Okay, we're going to look at the mathematical literacy and vocabulary worksheet. So we've got some vocabulary to do. Let's see what we got here. So conjecture. Remember, a conjecture cannot be proved. It's something you accept as being true. So a conjecture is what you think might happen or might be true based on what you have observed. So a conjecture might be the streets are wet, so I think it's been raining. Okay. A counterexample is something that basically shows that a conjecture is false. And all it takes is one example of a conjecture being false or not working to have the whole conjecture be false. So we could say it's we need one example that shows the conjecture does not work. And all it takes is one. So all trees lose their leaves in the fall. The counterexample would be evergreen trees have needles that are leaves and do not lose them in the fall. So this one counterexample basically shows that this is not a true statement. Now, inductive reasoning is reasoning from patterns. So we could say that inductive reasoning is a hypothesis based on an observation or based on a pattern. So based on like this pattern here, 5, 10, 15, 20, you're thinking the next one could be 25, then 30, then 35, then 40, because the 5s keep on going as multiples. And we'll do some problems that are like this too using inductive reasoning. A pattern is an arrangement or ordering. You can extend a pattern if you know the rule for the pattern. So an example I came up with is, let's talk about this Fibonacci sequence, which you might have heard of before. You start with 1, your next one is 1, and then you start adding to the previous. So 1 plus 1 gives you a 2, 2 plus 1 gives you a 3, 3 plus 2 gives you a 5, 5 plus 3 gives you an 8, 8 plus 5 gives you a 13, and 13 plus 8 gives you a 21, and then we get 34, and it keeps on going. And at some point we'll watch a video with cones and spiral patterns in cones and sunflowers that basically the spirals use different consecutive numbers in the Fibonacci sequence. So this is a sort of like a number pattern that seems to be just kind of made up, but it does actually occur in nature. Another pattern might be, let's see, we start with a triangle, then we make a square, then we make a pentagon, then we make a hexagon, then we make a heptagon, then we make an octagon, and so on. So we got like an 8, a 7-sided figure, a 6-sided figure, a 5, a 4, and a 3. And then we go nonagon, 9-sided, decagon, 10-sided, and so on. So you can have patterns also with shapes. Another pattern might be M, T, W, T, F, S, and you want to know what the next 2 are. Well, if you think about the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, we've got Sunday, and then we got Monday, and then the pattern keeps repeating. So these are examples of patterns. And a lot of our inductive reasoning work is going to be trying to identify patterns. And a prediction is similar to a conjecture as something that you think might happen based on what you observe. So I predict that tomorrow the sun will come up. Sun will rise. Oh, let's say before 7 a.m. So that's my prediction. Let's see if it happens. Okay, so that's that for these.